welcome to my channel. In this video you are going to see how to solve the system of linear equations by using Gauss elimination method. Actually in my previous video also I have done the same thing. The main difference is that there I have done for 3 equations. Now I am going to do for 4 equations by using Gauss elimination method. Let us go into the video. So the given problem is solve the system of equations by using Gauss elimination method. So you can see 4 equations. 6x1 minus 2x2 plus 2x3 plus 4x4 is equal to 16. 12x1 minus 8x2 plus 6x3 plus 10x4 equal to 26. 3x1 minus 13x2 plus 9x3 plus 3x4 is equal to minus 19. Minus 6x1 plus 4x2 plus x3 minus 18x4 is equal to minus 34. So whenever the system of equation is being given, the first step is we have to put in terms of augmented matrix, that is this A is to B. We know that B is nothing but the numbers in the right hand side. So that is going to be 16, 26, minus 19 and minus 34. And then the matrix A, all the coefficients of x1, x2, x3, x4. So when I put all this, I am getting this is going to be the matrix A and this is going to be B. So the next step is this matrix A we need to bring in terms of upper triangular matrix. So upper triangular matrix in the sense the elements below the principal diagonal I have to make it 0 or I have to nullify. So this is going to be your principal diagonal. So the elements before the principal diagonal is going to be 12. I have to make it as 0 as well as 3, minus 13, minus 6 and 4. So how you are going to make it as 0, like previously how we have done the same way by using simple elementary row transformation, it is possible to make them to be 0. So here my first transformation is R2 minus 2R1. By using this transformation, I can make this 12 is going to be 0. So I have to multiply row 1 with 2 and then subtract from R2. So when you do this, you will be getting the second row as 0, minus 4, 2, 2 and minus 6. So the 12 is becoming 0. And then the next transformation is I have to make that 3 and minus 13 to be 0. Then for that again to make the 3 as 0, I am going for another transformation R3 minus half R1. That is the row 1 I am multiplying by half and then subtracting from R3. So by doing that, so how the R3 is being changed is 0 minus 12, 8, 1 minus 27. So now R3 is completely changed and this 3 also becomes 0. So we made it as 12 as 0, 3 as 0. Now our next is minus 12 is there and minus 6 and 4 and 1 also is there. So to make that 0, we are going for the another transformation R4 plus R1. R4 is this one, R4 plus R1. By adding that, I can make that R4, the minus 6 will become 0. So by doing that, what happens is the row will become like this. So R4 plus R1, by using it, I am getting 0, 2, 3, minus 4, minus 18. That is, the row 4 is changed in terms of the transformation R4 plus R1. So the first 3 elements we made it as 0. Now the left out elements we have to make it. For that I am going to, I have to make this minus 12 to be 0. For that I am using that another transformation R3 minus 3 R2. And similarly I have to go for this 2 as 0. For that I am going for the transformation R4 plus half R2. You can ask how to make all these simple calculations. So how it is possible, it's a trial and error method only. So just how it is possible to make them 0, because all simple numbers, so easily it can be made by using simple transformations. So here, so going R3 minus 3 R2, so I have to multiply the second row. So the second row to be multiplied by 3 and subtracting from R3. So by doing so, I am getting this minus 12 and this is going to be 0. So 0, 0, 2, minus 5, minus 9. Similarly, the fourth row I am going for a change as R4 plus half R2. That is multiplying R4 by half and then adding with R4, R2. So R4 plus half R2, in the sense I am multiplying the row 2 by 2 and then adding with R4. So I will be getting 0, 0, 4 minus 13 minus 21. So what is left out is only one element left out, that is the 4. So 4 to be 0. So for that I am going for the transformation as R4 minus 2R3. That is, I am multiplying R3, row 3 with 2 and then subtracting from R4. So by doing so, I am able to get that this 4 also is going to be 0. So we'll be getting 0, 0, minus 3, minus 3. So now the entire matrix A has been brought in terms of an upper triangular matrix, and this is a principal diagonal, and all the elements below the principal diagonal, we are able to make it in terms of 0. Hence, this is in the form of upper triangular matrix. So now let us going to use the backward substitution. So backward substitution is, what is that equations you are getting out of this matrix is minus 3x4 is equal to minus 3. That implies x4 is equal to 1. And the previous one is 2x3 minus 5x4 is equal to minus 9. So 2x3 is equal to, already you are substituting for x4 as 1. So you will be getting x3 is equal to minus 2. And the third equation is minus 4x2 plus 2x3 plus 2x4 is equal to minus 6. So let us substitute for x3 and x4, and I'll be getting the value of x2 as 1. And the first equation is going to be 6x1 minus 2x2 plus 2x3 plus 4x4 is equal to 16. So since already we know x2, x3, x4, so substituting all the values, I am able to find out what is x1. x1 is going to be 3. So the final values are x1 is 3, x2 is 1, and x3 is minus 2, and then x4 is equal to 1. That is the solution for the given system of linear equations. So this is the way we need to solve any equation by using Gauss elimination method. So it's very easy. The steps are same. Only thing, little more accuracy is required when we perform the elementary transformations. Good luck. See you in the next video. Bye.